Hello students, welcome back to my channel. Today I have come with questions based on magnetic effects of current and electromagnetic induction, which were asked on 30th January 2023 JEE mains. Both morning and evening, that is both shifts combined, I have taken the questions together, okay? So let us solve them one by one. So here comes the first question. The magnetic moments associated with two closely wound circular coils A and B of radius this much and this much respectively are equal if. Now what is the formula for magnetic moment? Okay. Magnetic moment of a circular coil. In fact, for any planar coil, magnetic moment is given by A into N into I, where A is the area, N is the number of turns, and I is the current carried by it. Okay. Now since it is circular, so I'll write this as pi r square into N into I. So, so for the first, radius is 10 cm, so 10 centimeters square. Number of turns is Na and current is Ia. That should be equated to, for the other one, the radius is 20 centimeters square and number of turns is Nb, current is Ib. So after cancelling all of them, we are left with NaIa is equal to 2 to the 4 times NbIb. So C option is the correct option. Then moving on to the next question. A massless square lobe of resistance 10 ohm supporting a mass of 1 gram hangs vertically with one of its sides in a uniform magnetic field of 10 power 3 Gauss directed inwards in the shaded region. You can simultaneously look at the figure as well. A DC voltage V is applied to the loop. For what value of V, the magnetic force will exactly balance the weight of the supporting mass. Now here students, we know when when a current flows, when a current flows in a wire which is inside a magnetic field, which lie within a magnetic field, then there will be a force. Okay, the force should be upward, so it should be directed outwards. Yes, it is directed outwards, not inwards. This is wrong, students. By mistake, it has been taken. So, if magnetic field is along the outward normal and current flows in this way, it will experience a force equal to BIL. Okay, because B, I, and L each are at right angles to each other. B and I and L are the same. B and I are perpendicular to each other. So if this balances this, then we can write B into I into L is equal to Mg. Okay. So what is the magnetic field given? Magnetic field is 10 power 3 Gauss. Divide by 10 power 4 to convert this into Tesla, because we will be proceeding in SI unit. Then current is how much? Voltage upon resistance. Resistance is 10 ohm. Into length. Length is 10 centimeters given. So 10 centimeter means 1 by 10 meter is equal to mass. Mass is 1 gram. So 1 gram to be converted into kilogram divided by 1000 and G is 10. So I hope this should give us the answer. Is it? So 10 power 1 zero gets cancelled here. Here two zeros gets cancelled here. So V is 10 volt. Okay. This 10 goes up that side. So D option is the correct option. Moving on to the next question. In a series LR circuit with XL equal to R, power factor is P1. If a capacitor of capacitance C with XC equal to XL is added to the circuit, the power factor becomes P2, the ratio of P1 and P2. Now in the first situation, it is an LR circuit. Okay. And one of them is inductor. XL is equal to R. Okay. So net impedance for this net impedance will be under root R square plus XL square, which is equal to root 2R. Okay. So the power factor, you can see, is R, this is X, and this is Z. This cos of phi is the power factor. So power factor is how much? Cos of phi, which is R by root 2R, that is 1 by root 2. Then in the next case, as you can see, if a capacitor of capacitance Xc equal to XL is added, when Xc is equal to XL, the net reactance will become 0, net reactance, and accordingly, the net impedance will be only equal to R, because as you know, the reactance becomes 0 here. See this part is 0, this part is 0. So Z will remain R itself. So in such a case, it is a pure resistive, okay, and it is in resonance. So in such case, power factor is 1 because there is no phase difference between voltage and current. So accordingly, phase difference being 0, cos of 0 is 1. So if we get the ratio P1 by P2, if you obtain the ratio P1 by P2, then 1 by root 2 is to 1. So B option is the correct answer. Then moving on to the next question. As shown in the figure, a current of 2 ampere flowing in an equilateral triangle of side this much. The magnetic field at the centroid of the triangle is. Now students, you have to find the magnetic field due to each side and multiply it by 3 by symmetry, because each of the three sides will be contributing equally to the magnetic field at point O. So it's a matter of just applying a formula for magnetic field due to a straight wire. I'll write down the formula. You see, magnetic field due to a straight wire is, join the end points there. Let one of the angle be alpha, the other angle be beta. This is a perpendicular, and let this perpendicular distance be A. Then, and let the current carried be I. Then the magnetic field is given by mu 0 by 4 pi into I by A multiplied by, here you have to multiply by sine alpha plus sine beta. This is the formula. So for one side, let us take this side, just join the end points, okay, and then drop a perpendicular. So as you can see, each angle will be 60 degrees each. And this side we have to find. Total side is given, side of the triangle is given. We'll be finding this. For now, let us take it as A, not a problem. So magnetic field due to each wire of the three wires, we are calculating field due to each wire, is mu 0 by 4 pi into I by, for now I'll write it as a sine 60 plus sine 60, that is 2 times of sine 60 degree. Sine 60 degree is how much? Root 3 by 2. So 2 gets cancelled here. We are left with this much. So net magnetic field will be 3 times of this due to each of the 3 wires by symmetry. So this will be mu 0 by 4 pi into I root 3 into 3 by A. Now we have to calculate A. Okay. As you can see, it's very simple to calculate it. This distance is half of the side, that is 2 root 3. And okay, and this angle is 60 degree, or this angle is 30 degree, either way you can do. So A will be equal to, from this right angle triangle with respect to this angle, you can see with respect to this angle, A is 2 root 3 into tan 30 degree. 2 root 3 into tan 30 degree. Tan 30 degree is 1 by root 3. So A is 2. So just it's a matter of substitution here. Okay. So mu 0, okay. Mu 0 by 4 pi is 10 power minus 7. So let us substitute the values here. So 10 to the power minus 7. I is how much? 2 ampere. A is 2 into root 3 into 3. So 3 root 3 into 10 power minus 7. Now this is centimeters, students. So we have to convert this into meter. So we have to divide by 100. So this which will go up and become plus 2. So minus 7 plus 2 is 10 power minus 5. So we are left with 3 root 3 into 10 power minus 5 Tesla. So this is the correct answer. Moving on to the next question. A current carrying rectangular loop PQRS is made of uniform wire. The length PR and QS is 5 cm and PQ and RS is 100 cm. If ammeter current reading change from I to 2I, the ratio of magnetic forces per unit length of the wire PQ to the wire RS. Now you see here, the currents will be same here in both the wires, okay, PQ and RS. What will be the current here? No matter, these two wires will have the same current. In fact, currents will be divided in the equal ratio. So when current is I initially, here each will carry I by 2, I by 2. And when the current is 2I, each will carry I and I. So for now, I am taking I as the current here. Okay, since currents are equal. So magnetic force per unit length of the wire PQ, per unit length of the wire PQ will be mu 0 by 2 pi into product of the currents divided by separation between them. What will be the separation? Let us take this as D. They have given it as 5 cm, of course. So 5 cm. Now in the two situations, when the current is changed from I to 2I, you can see only this current changes. So the force is proportional to square of current. So if we can find the factor of change for current, automatically we can find the factor of change for PQ. So factor of change of current is 2. So 2 square is how much? 4. So factor of change for force is 4. In other words, the new force will be 4 times the original force. So F dash by F will be, sorry, initial to final we have to find. So just opposite, reverse of that. Initial force to final force. Initial to final means this will be 1 by 4. I hope that is clear. Then moving on to the next question. In the given circuit, RMS value of current through the resistor is. Now, this is very simple question, students. You just have to find the net impedance of the circuit. Net impedance of the circuit, and you know that voltage applied. Voltage upon net impedance will give you the total current. So, in order to know the net impedance, you should know the net reactance as well as resistance. So, you can see net reactance is 200 minus 100. It is the difference between the inductive and the capacitive reactance, and this also R. So if you draw the impedance triangle, then you have 100, this is also 100, so Z will be 100 root 3, root 2, sorry. Okay. So IRMS is equal to VRMS upon Z. So VRMS is how much? 200 root 2, and Z is how much? 100 root 2. So we have 2 ampere. So the option is the correct option. Yeah. Moving on to the next question. As per the figure, if di by dt is minus 1 ampere per second, then the value of VAB at this instant will be. Now we'll start from point A and we'll reach point B. Okay. Probably VAB means the difference in potential between point A and point B. That's what it means. So let us say potential at A is VA and that at B is VB. So I can write like this. Starting from here, VA. If I see the current is flowing in this direction, if you move in the direction of current, the voltage will reduce. It is similar to like if you go in the direction of flow of water, the level will reduce, isn't it? Because water always flows from higher level to lower level. So suppose a stream is flowing from a mountain, you are moving in the direction of stream flow. So naturally you are coming down. In other words, your level is reducing. So here also potential will reduce. So minus, as per Ohm's law, it is I into R. So 2 into 12 is 24. Then as you move in the direction of current, again there will be an opposition. So if the induced EMF can be represented by some cell, perhaps the cell will be something like this. So you are basically moving towards the negative term. So minus L di by dt. L di by dt. What is di by dt? Di by dt is minus 1. Then again you are moving towards the negative terminal of the cell. So again minus 12. You reached point B. So VB. So therefore I can write VA minus 24 minus plus minus 6 and plus 6 and minus 6 is minus 6. So VA minus VB is 24 plus 6, that is 30 volt. So 30 is the answer. Then moving on to the next question. In an AC generator, a rectangular coil of 100 turns each having area this much is rotated at 360 revolutions per minute about an axis perpendicular to a uniform magnetic field. So the diagram will be something like this. This is the area vector and magnetic field lines will be like this. So if you can calculate the magnetic flux, it is number of turns into A into B into cos theta. Now as per Faraday's law of electromagnetic induction, induced EMF will be minus d phi v by dt. Okay, d phi v by dt. So if as you differentiate this, N, A, B are constants, only theta is changing, you can see. as the coil rotates. Let us say the angular velocity is omega. Then, sorry, derivative of cos theta is minus sin theta minus sin theta d theta by dt. And d theta by dt is omega. So omega into NAB into sin theta. Now, if we are interested in the maximum value of EMF, we should take sin theta, maximum value of sin theta, which is equal to 1. So accordingly, you have the formula omega into NAB. This is the maximum induced EMF possible. So it's a matter of substituting the values. So omega, since frequency is given as 360 revolutions per minute, it will be 2 pi f. F is 360 revolutions per minute, means per second it is 360 by 60, that is 6. So this much radian per second. Number of turns is 100. Area is 14 into 10 power minus 2. 14 into 10 power minus 2, and magnetic field is 3. So let us cancel 100 and 100 here. Now 7 2s are 14. So we are left with 44 into 36. So 44 into 36 will be how much? 4 6 is 24, 4 carry 2, 4 3 is 12, 144, and then 144. So 4851. So you have 1584. This is the answer. 1584. That's all in this video, students. Thank you so much.